So the given problem is determine the Cartesian coordinates of the point P which has local coordinates epsilon is equal to 0.8 and eta is equal to 0.6 as shown in figure. So if you see the figure, the coordinates of the quad element is being given. So the node numbers are noted as 1, 2, 3, 4 with respect to the clockwise, anti-clockwise direction. So the coordinates for each nodes are given, and this element is being formed with respect to the natural coordinate system. So the question is, you have to determine the Cartesian coordinate of the point P. Okay, the point P is here, so you have to determine the Cartesian coordinates here. So now what's the step we have to do? The global coordinates of this element, of this quadrilateral element which has 4 nodes. Okay, so the Cartesian coordinates given, we have to write the given y1 equal to 4. So the x1 y1, x2 equal to 9, y2 equal to 6, x3 equal to 8 and 12, y3 12. So x4 is equal to 5 and y4 equal to 10. So you can take any units. So we don't know that unit, centimeter, mm, we don't know. So you can take it as a unit. Okay. So the local coordinate of the P is given. The P coordinate with respect to eta is equal to 0.8, psi equal to 0.6. So these are all the given data. Okay. So now what we know, this coordinate function, this quadrilateral element, we know the shape function equation. Okay, so with respect to the Cartesian coordinate, the point P, this point P can be expressed in an equation like x equal to the Cartesian coordinate of the point P, n1 x1 plus n2 x2 plus n3 x3 plus n4 x4. So similarly with respect to y coordinates, n1 y1, n2 y2 plus n3 y3 plus n4 y4. So we have seen this equation already. Okay, so this equation, the Cartesian coordinates at point P. So this is the equation. So we know the shape functions of n1. What's that? We have already derived the 4 shape function, 4 nodes. So 4 shape functions will be here. So 1 by 4, 1 minus eta, 1 minus psi. n2 is equal to 1 by 4, 1 plus eta, 1 minus eta. n3, 1 by 4, 1 plus eta, 1 minus eta. Okay. So n4 is 1 by 4 minus eta 1 plus psi. So this is the shape function. Now we have to substitute the corresponding values here. So we need the shape function at this point P. Okay. So say why shape function is used? Shape function is connecting the global variable to the local variable. So that's why we are going to use and find the shape function here. Okay, 1 by 4, 1 minus 0.8, 1 minus 0.6. So we know 0.4 and 0.2 and divided 4 is equal to 0.02. Again we have to substitute at node number 2. What's the equation? 1 plus 0.2, 1 minus 0.6. This is equal to 0.18. 1 by 4, 1 plus 0.8, 1 plus 0.6. Okay, this is plus. It's equal to 0.72. 1 by 4, 1 minus 0.8, 1 plus 0.6 is equal to 0.08. So we have calculated using calculator. So you guys also try to calculate using this equation using calculator. Okay, so now we have found the shape functions at each nodes. Okay, so once we substitute the values of shape function, nodal coordinates in equation, that is we take it as a equation 1. Okay, so nodal coordinates at the equation 1 we can substitute. So we get the Cartesian coordinate at a point P. So let's see how we do it. The equation 1, we will write it again. N1 x1 plus N2 x2 plus N3 x3 plus N4 x4. So we substitute this equation x1 y1 value. We already found N2 we know 0.18 and the x2 coordinate is 9. Okay, plus 0.72 x3 value we know 8 plus 0.08 into 5. So let's calculate this using calculator. 7.84 is the unit we said already. We will mention it as units. So we similarly calculate with respect to y coordinate. What's the equation? Plus n2y2 n3y3 plus n4y4. So we found that we know already the shape function values into 4 plus 0.18 into 9. So you directly see this value and write it, only the coordinate will be different. 0.72 into 8 plus 0.08 into 5. So using the calculator we know that the value is 10.6. So the Cartesian coordinate we have already found now. So the Cartesian coordinates at point P, so let's assume it's x and y, is 7.84, 10.6. This is the answer. Units. Okay, so that's it. So students, you might be well aware how to find out the Cartesian coordinate using the natural coordinate system and shape function. So let's see in the next problem.